Hello everyone. Today we're going to solve an example related to projectile motion. Let's now solve a problem related to a projectile motion. In this case here, a projectile is launched from the top of a 9-meter high building at a velocity of 20 meters per second, forming an angle alpha in relation to the ground. It is known that the acceleration of gravity is 9.8 meters per second squared, and this angle here, the sine of this angle is 0.6. So let's determine the distance from the building the projectile will reach. We want to know this distance here in the x direction. To calculate this distance, we need first to find how much time the projectile takes to stop its motion, to reach the ground here. We can do it by using the space equation in the y direction, the vertical direction. We know that it's an accelerated motion, so we use this expression here. We also know that for the y component of v0y, we have that v0y equals v0 times the sine of this angle here. We also know that when the projectile touches the ground, at this point, y equals 0. If we add these two things here in the space equation, it becomes this expression. So, continue with the calculation here. We can add the values to the space function. We have 0 equals 9 meters of the building, 20 meters per second times the sine of the angle, which is 0.6, and also add the gravity acceleration. Well, solving this, we reach in a second degree equation. If we solve it for t, we have two numbers, a negative number and a positive number. Of course, we're dealing with time here, so only the positive number makes sense. So the time that it takes to reach the ground is 3.05 seconds. Now for the distance in the x direction, we can use this expression. We know that the distance is the velocity times the time. We also know that this velocity in the x direction equals the velocity here, 20, times the cosine of this angle. Well, we already know the sine of the angle, so we can find the angle itself and then the cosine of the angle, which is 0.8. Adding the values to the formula, we have the velocity 20 times the cosine of alpha 0.8 times the total time to reach the ground, to touch the ground, which is 3.05. Solving this, we have a distance of 48.8 meters. Okay, now it's your turn. So imagine that a large rock is ejected from a volcano with a speed of 25 meters per second at an angle of 35 degrees, as shown in this image here. So the rock strikes the side of the volcano at an altitude of 20 meters lower than its starting point, and then you have to calculate the time it takes the rock to follow the path and what are the magnitude and direction of the rock's velocity at the impact. Try to solve it and comment down below your answers.
Physics can be easy. Subscribe to our channel and learn with the geeks.